We are going to start verifying trig identities. That is what 5.2 is all about. Identities. So what's going to happen is we're going to have an equation, and we are going to have to get the right side to equal the left side. Okay? One of the biggest things that we want to make sure that we do is we want to just work only one side. All right? So there are a lot of different ways and techniques that we can go about doing this. My suggestion to you is maybe start with the longer side, the one that kind of looks a little bit harder, and see how you can manipulate it. Okay? So at any time, if you want to pause the video and try some on your own, feel free. And if you noticed that if you did pause the video and how you answer a problem is a little bit different than me, that's fine. As long as mathematically your steps make sense, you're okay. All right, so I need to get the left side to equal 1. It's a lot easier to condense something than to expand another thing. So that's what I'm going to do. So the first thing I'm going to do is I'm going to condense the cosecant squared theta, squared of x, minus 1, using my Pythagorean identity. And I know that that equals cotangent squared x. I'll put a little equal sign. These are reciprocals of each other. Reciprocals will always cancel each other out, leaving you with 1. And notice 1 does equal 1. You have verified your first problem. All right, now that we've gotten our feet wet, let's go ahead and try a little bit harder one. So this one is secant x cosecant x is equal to the tangent x plus the cotangent of x. So when we're looking at this, right, we want to transform the more complicated side sometimes. So for me, looking at this, I think it's going to be easier to get rid of that addition sign than turn a multiplication sign into an addition sign. So that's what I'm going to do. So the next thing that I want to do is also kind of break it down into sine and cosine. Whenever I get stuck, that's what I do. I look to see, can I do sine and cosine? So I'm going to rewrite tangent. Tangent is made up of sine over cosine, and then I'm going to rewrite cotangent as cosine over sine. So now I'm dealing with a fraction. Fractions, in order to add them together, we need to have a common denominator. So I'm going to go ahead and multiply the top and bottom by cosine over here, and the top and bottom by sine over there. So this should give me sine squared x all over sine x cosine x plus cosine squared x all over sine of x cosine of x. I notice that my numerator, if I write it all together, is starting to look like a Pythagorean identity. So I'm going to go ahead and rewrite this guy as just 1 over sine of x cosine of x. And what else do I notice? I can always break up my denominator when it is written as 2. So I'm going to come up over here. So this is really 1 over sine of x times a 1 over cosine of x. Well, 1 over sine of x is equal to cosecant, and 1 over cosine of x is equal to secant. So I can go ahead and I can change those around and rewrite it towards the other side. A little check mark off that, and notice that we have verified another equation. Right side is equal to the left-hand side. There's a lot of strategies that we can use, right? We can try to simplify complex fractions, we can factor. So I want you to try example 3 on your own. So sine squared x all over cosine squared x plus sine x cosecant of x is equal to the secant squared x. So see which side makes it a little bit easier and try to get the left side to equal the right side. All right, so for me, again, the left-hand side looks a little bit easier. I'm going to manipulate this guy first, and that is tangent squared x. And then what do I notice over here is they are reciprocals of each other. Reciprocals always multiply to equal 1. Well, look at that. I got a Pythagorean identity here, and this Pythagorean identity tells me that this is the secant squared x. And notice secant squared x is equal to the secant squared x. Right side is equal to the left side. All right. Let's keep going. Let's try another example. Call this example number 4. Secant of x minus 1 all over 1 minus cosine of x is equal to the secant of x. Again, if you want to try to pause the video and manipulate this one on your own, feel free. So for me, what I'm going to do is I am going to try and make my numerator and denominator kind of have similar similar things. So what I'm going to do is I'm going to rewrite secant as 1 over cosine of x and then minus 1. This will be my numerator. Put a little division sign and 1 minus cosine of x. Common denominator, so if I make this be a common denominator, I'd have to multiply cosine of x by cosine of x. So this will be 1 minus the cosine of x all over the cosine of x, combine like terms, again, and divided by 1 minus the cosine of x. Division is the same as multiplying by the reciprocal. So 1 minus the cosine of x all over the cosine of x. So it's as if this was all over 1. So this will be 1 over 1 minus the cosine of x. So what do we notice? We notice that this is a binomial. So I'm going to put a little parentheses around that. And this whole binomial, 1 minus cosine of x, is going to cross off with that whole binomial. And what do we have left is 1 over cosine of x. 1 over cosine of x is equal to the secant of x. Bam. Verified. Now there was some other ways to do that. This was the easier method of the two. All right. Let's try something a little bit different. So this will be example number 5. 1 minus the cosecant theta minus the cotangent of theta is equal to the cosecant of theta plus the cotangent of theta. So when you're looking at this problem, again, we're trying to figure out what side is a little bit better. I think it's easier to get rid of a fraction than to make that become a fraction. So one of the things that we can do is we can multiply by conjugate. So don't forget your lovely friend the conjugate. So that just means I'm going to multiply the top and bottom by the same binomial except making that positive. So I'm going to go ahead and just quickly erase number 5 for a moment. Put 5 up in the corner. So that means I'm going to go ahead and multiply top and bottom by this. So 1 times all of this is just going to say the cosecant of theta plus the cotangent of theta. It's as if we put parentheses around that. Cosecant and cosecant. This will be a cosecant of theta times the negative cotangent of theta, positive. That's all going to cancel out. And then finally minus the cotangent squared of theta. So at this point, I want to try to manipulate one and the other. So I'm going to go ahead and I'm going to remove the cosecant of theta. I'm going to use a Pythagorean identity. And I'm going to rewrite it as 1 plus the cotangent of theta. So the reason why I'm doing that is because I noticed that what I want was a positive cosecant of theta and a positive cotangent of theta. I noticed that I got both of those, but I needed to get rid of my denominator. So I needed the cotangent to cancel each other out. So notice here that a positive cotangent of theta and a negative cotangent of theta will cancel each other out, leaving you with just the numerator. Technically, we have a denominator of 1, but that's the same thing as having a denominator of 1 over here. And so this is the start of verifying your trig identities. All right.